Easy, James here. Now, how many videos have you seen on YouTube of people showing you their crazy deck mods? You know, like put different colour LEDs in the buttons and painted the faceplate and stuff like that. Now, it looks pretty cool, and you know, I respect the fact that you'd want to do that. It's great, and I think this is what's inspiring a lot of people to do this and, you know, mod up their decks and stuff. Now, don't get me wrong, it's great, but these videos don't really give you any advice. They just show you, you know, what people have done. And trouble is, people look at these videos and they think, oh, if he can do it, anyone can do it. So they start ripping their deck apart, and then, you know, the result is they can end up breaking it, as a few people have done, because I've got a few emails, some people saying that they've done a bit of damage to their deck because they've tried to mod it up and basically made a bit of a mistake, and their deck's gone bang. So what I'm going to do is I'm going to cover, there's quite a few different problems where people are having, like, one guy said that he accidentally shorted out the LEDs in the strobe illuminator and now that doesn't work. Another person saying that they've put the LEDs in and it hasn't worked, so they put the original LEDs back in and it still hasn't worked. Somebody saying they've tried to test the voltage on there, and when they did, they touched two of the LEDs together and now them two don't work. So a different range of problems, but basically you've probably done pretty much the same thing by shorting it out or by putting the LEDs in the wrong way around or whatever. So what I'll do is I'll just show you a couple of things that you might have done and, you know, show you how you can get onto repairing it. Now, I wasn't going to do any of these videos about modding, but, you know, if people are going to start going and breaking their decks, it looks like I'm going to have to now. So what I'll do is when I get 5 minutes to order in some LEDs and get 5 minutes to do a video, I'll show you how to put the LEDs in the strobe illuminator and do it, upgrade them for different colour LEDs. But first of all, though, we'll look into fixing the problem. So basically, if you've shorted the LEDs out, anything like that, there's one thing that you may have damaged, and that's a transistor. I actually made a reference to it in my last video, but what I'll do is I'll do some crazy doodling, because we haven't done any of that for a while, have we? So I'll do a bit of that, and I'll start by showing you how this thing's wired up, so you can get a better idea of how it works and, you know, how to repair it. So what I'll do is then I'll move the camera, get some paper, and we'll get doodling. Right, now I've drawn a little bit of this out already, okay. Now this part here is AN6680, and this is the IC that's inside the deck. This part here, and this is just a basic driver IC, and I've only drawn in pin 10 and 11 because these are the only two we're going to worry about, okay. Now down here, these are the 4 diodes that are in the strobe illuminator, or the LEDs, and this is a resistor, which is this one up here, and this is R212. It's next to the lamp fitting, and it's a 150 ohm resistor. Okay, now you get 20 volts going through the resistor, okay, down to the LEDs. Now these LEDs are wired in series. Now, in case you don't know, LEDs, or light emitting diodes, are essentially exactly what they say on the tin. They're diodes that emit light. Now, because they're diodes, they are polarity sensitive, which means if you get them the wrong way round, they won't work. Now, because these are all in series, if you get just one of these the wrong way round, none of them are going to work, okay? So you need to make sure that all of them are the correct way round. Right, okay, so looking at the chip now, we've got pin number 10. Now, pin number 10 is just connected to the ground, okay, on the turntable. Okay, now pin number 11 on this chip, okay, connects to that transistor that I was on about. Okay, now this is a NPN transistor, and this is the transistor here. Okay, it's over this side of the board. I showed you it in the other video. Now, if you notice on here, we've got B, C, and E. Okay, now you need to pay attention to those because they will tell you how to put the transistor in when you replace it. Okay, so B is base, C is collector, and E is emitter. So I'll go into now how this is wired up and how this works. And the emitter on the transistor connects straight to ground, and the collector on here connects to the LEDs, alright? And there's also a little cap on here. I can't remember what the value is. I think it's like 100 picofarads or something like that. It's a ceramic capacitor, I think. But anyway, that's not really that important. The important part is this transistor here. Now, it has 3 pins on it, and this is one here actually. I've got one which I wrenched out of an old Technics tape deck I had in the loft, and that's what it looks like. So on here, this one here is the base, this one, as I already said, is the emitter, and this is the collector. So what happens is, okay, the power is coming from your 20 volts through the resistor. Now when it comes down to the LEDs, it goes through all of the LEDs and then it goes up here to the collector on the transistor. Now normally that would just flow to ground and then that would complete the circuit and the LEDs would light up. But because this transistor is a semiconductor, it doesn't actually pass through the transistor unless there's a small amount of current going through this base, okay? Now this pin here, 11, puts out a square wave, okay, which looks like this. Okay, so it's doing that constantly, on, off, on, off, on, off. And what happens is, this here, I believe, is 0.9 volts, okay? So what happens is, when the chip outputs this point here, so when the voltage peaks here, out of pin 11, 900 millivolts into the base, and then that will allow the current to flow through the transistor to the ground, and the LEDs will light up. Now when it gets to this point down here, then the voltage is now at 0, okay, flat line, which means there's no more current on the base. This then becomes a really high value resistor, and the current can't flow to ground and the LEDs go off. So when it's up like that, the LEDs are on. When it's down like that, the LEDs are off, okay? Now that sounds really complicated. I'm trying to explain this as simply as possible, but basically this transistor here is what's controlling or driving these LEDs at the correct frequency so that they can work with the the little dots, okay? Okay, so in this circuit here, you've basically got two weak links, okay? You've got this resistor and the transistor here, okay? Now, if you short circuit this, either one of those could be damaged. More than likely it's going to be the transistor, but check the resistor as well. Now this resistor is 150 ohms. So what you might want to do is get a multimeter and connect your multimeter from this point here to this point here, and the reading between those 2 points should be 150 ohms. Now the thing is, this is a 5% resistor, so it could be within 5% of that value, but make sure it's around 150 ohms. Okay, so I've got the multimeter across the resistor here, R212, and as you can see on the multimeter we've got 148.9 ohms. Okay, so that resistor's fine. If that's the case, that resistor's fine, okay? No need to change that. However, if that's the case and that is fine, obviously the transistor is what the problem is, so you need to change the transistor, okay? So to do that, you need to basically desolder the transistor off the board. I can't actually do this, but I will show you basically how you do it. Okay, when you're desoldering the part, okay, I can't show you this on my deck because I don't want to go unnecessarily removing parts off my circuit board. But what you need is one of these things. Now this will make desoldering 100 million times easier, okay? Now this is called a desoldering pump, or some people call them a solder sucker. But essentially what it is, you press that down, okay, and then you press that button and that pops up and it sucks all the solder off the joint. Now these things, you can get these quite cheap. I mean, you can get them for about 10 quid here in the UK, maybe about, you know, $14, $15 US. Now this thing will make it just so much easier. Now what you do with this thing, I've got an old computer motherboard down here, I'll just show you on this. Now obviously you need to arm it, press that down, and then you get the tip of your soldering iron. Let's pretend that's the tip of the soldering iron, and all you do is you put the soldering iron on the back of the component that you want to desolder, on the solder joint there, and then you wait for the solder to flow. You may have to hold it on there for a good 2 or 3 seconds, and then when the solder's flowing and it's actually liquefied, what you need to do is, quick as you can, okay, put this tip of this on the end of the joint like that, and then press the button. and what it will do is it will just suck all the solder off the joint. Now you may have to do it a couple of times to get all of the solder off, but if you have to, don't worry, just do it as many times as you need to. But leave a gap in between doing each one, okay? So don't overheat the pad, otherwise you can break it. Now, what can happen is you can get what's called a sweat joint, which means all the solder's off, but there's just some dried flux or maybe a tiny bit of solder that's just holding it on. So don't yank it or pull on it, because you can break the pads on the board. Just grab the component from underneath and pull on it gently, and then just get the soldering iron and just touch it along all the joints on the back, and that will just break any sweat joints and it will come straight off. Okay, again, this is the transistor here, and the part number for this is here. It's 2SD637, okay? So you can get hold of these, they're not impossible to get hold of, but I have seen these on eBay, okay? So I know you can get these off eBay. But any good electronics outlet will be able to order these in for you. It's a Panasonic part, so it should be pretty standard part. But like I say, you will have to probably order these in specially, because they're not just a standard off-the-shelf part. So you won't be able to just go into like a Radio Shack or a Maplin's and get one of these. Now, if you can't get one of these, okay, you're going to have to try and get a replacement one. Now, unfortunately, you're going to have to do this at your own risk, because it's not an original part. So I'm recommending that you try and get the original part. But obviously, if you can't, obviously you've got no other choice. You've got to try and get another part. Okay, so if you can't get one of these, obviously you are going to have to seek a replacement. So a good replacement for one of these is one of these. Okay, now I will write the part number down for this. Now the part number for this is BC546B. Now one of these you will be able to get hold of, okay? These are really common, these ones. So you'll be able to get hold of these ones easier. Now the HFE values of these two are near enough identical. This one can't take as much load. This one can only take 100 milliamps. But the average switching load for those LEDs is going to be somewhere between 40 and 60 milliamps. So it's not going to be at its full load anyway. So that doesn't really matter too much, but the voltages of these are exactly the same, okay? So the collector to emitter voltage and the emitter to base voltages on these are exactly the same. So this will be a good replacement. Now again, like I say, unfortunately, I can't be held responsible. You're going to have to use this at your own risk. However, I have used these in the place of these before, and in my experience they've been absolutely fine, okay? So you'd be okay to use that, but like I say, I've got to cover my arse in, really. So there you go, so you can use that. These you can get hold of. Now there is one more thing you've got to watch out for though, okay? And that is the pin out of these things. Now going from pin 1 to 3, on this one, pin number 1 is base, pin number 2 is collector, pin number 3 is emitter, whereas on this, pin number 1 is a collector, pin number 2 is base, and pin number 3 is emitter. So you can't just solder this straight in the same as that. You're going to have to put some heat shrink tubing or something to insulate these, and you're going to have to bend them into the right order to get them into the slot. So heat shrink tubing will probably do you a treat on this one, okay? So put that down there, insulate the pins, and then bend these so they're in the right order to put them in the place of that one. Now hopefully you shouldn't have to do this, because you should be able to get hold of one of these, hopefully. So there you go. I'm sorry that wasn't really straightforward. I appreciate the fact that was a bit complicated, but unfortunately that's the way things are. It's either that or you can take it to a shop and get it done, but they will charge you quite a lot for doing that. Now if you've got the money to burn and you can afford it, then go for it and take it to the shop. But I mean, if you haven't got the money to get it repaired and you want to give it a go yourself, and then you can give it a try. Worst case scenario, you might end up bollocksing up a couple of transistors. But there you go. I hope this video has been a help. Thank you for watching. Nice one.